Recording progress.
Hi guys, very good morning. This is Nikhil. Sorry for yesterday I couldn't upload the videos, so I regret it for. I apologize for this, and I today continue. I continue today this lecture. From the in the last lecture means day before yesterday we had covered up to this, so I have to start today lecture from this. Before going to start Before going to start the lecture, I first of all I am going to introduce myself. This is the Nikhiljan. I am the AI engineer, and I have planned to upload the videos related to the interview point of view, which are the only entry or exit gate. You can say both. For someone, this is entry, or someone for this is exit. So that keeping in mind, have planned to record quality lecture keeping in mind or interview. And thank all this is about me. And now let's move and jump to the our and dive into the lecture. Free tree pruning. What does it mean? Tree pruning is the method of trimming down a full tree to reduce the complete complexity and variance in the data. One second, guys. Tree pruning is the method of trimming down a full tree to reduce the complexity and variance in the data. Are you getting, guys? Once that yourself, please, so that you can better understanding, and if you getting the problem to understand the meaning, then I definitely make clarify your doubt. So for this, once that yourself, please. Have you read it? Once again, tree pruning. Tree pruning is the method of trimming down a full tree to reduce the complexity and variance in the data. Tree pruning is the method of this is the method of trimming down a full tree. Trimming down a full tree means cut into pieces in a small pieces. Cut means reduce the size of a tree to reduce the complexity to reduce the complexity and variance in the data. Why does we do this? To reduce the complexity and variance in the data. Purpose of behind this to reduce the complexity and variance in the data. That is why we do this tree pruning. Why do we do tree pruning? To Tree pruning is the method of trimming down a full tree to reduce the complexity and variance in the data. Are you getting meaning of this? This is a very important meaning. And must everyone must get this meaning. And tree pruning is the method of trimming down a full tree to reduce the complexity and variance in the data. Just as we regularized linear regression, we can also regularize the decision tree model by adding a new term. Just as we regularize linear regression, we can also regularize the decision tree model by adding a new term. Just as we regularize linear regression, we can also regularize the decision tree model by adding a new term. As just as we regularize linear regression, we can also regularize the decision tree model by adding a new term. This is the equation. This is called non-overlapping region, or this is called subtree, or alpha is called non-negative tuning parameter. Note, take the situation which has maximum residual. 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 That means you have to consider only those situations which has maximum residual. Okay, guys, this is you can get idea before pruning, after pruning. Say, are you getting? Are you able to make distinguish between them? This here, this node, right? This node. There is no connection. This is free. This is that node. Now this is active. You can say here. You can say that because there is no action. There is no any uh, means electronics waves are coming from this. I mean there is no passing of any information from this node. Like this is the pruning. This is the pruning. Also we can remove neuron, but it is present is there that free, but you could also remove this. Before pruning, before pruning, before pruning, after pruning, after pruning, after pruning, and this is the meaning, physical and geometrical interpretation, where now they are explaining the terms here. We are a mean of all the response variable in the region M, where T sub T, which is a subset of the full T2 alpha, non-negative tuning parameter which penalize the MSC with an increase in T length. By using cross validation, such values of alpha and t are selected for which our model gives the lowest test error rate. By using cross validation, such values of alpha and t are selected for which our model gives the lowest test error rate. By using cross validation, such values of alpha and t are selected for which our model gives the lowest test error rate. That means we have to consider only those values of alpha and t for which our model gives lowest test error rate. Lowest test error rate. Lowest test error rate. That is the meaning. This is how the decision tree regression model works. Decision tree regression model works. This is the working or decision tree regression model. Okay, guys, this is how the decision tree regression model works. This is how the decision tree regression model works. This is how the decision tree regression model works. This is how the decision tree regression model works. Post pruning. Post pruning. This pruning. Post pruning. Post pruning. Post pruning. This pruning. Post pruning. Post also known as backward pruning. Post pruning also known as backward pruning. This is the question which might ask in interview. So please do keep in mind this. Post pruning means also known as backward pruning. Post pruning also known as backward pruning. Okay guys, post pruning means also mean backward pruning. And what does it mean? Is the process where the decision tree is generated first and then non-significant branches are removed. Here is the first process is the process where decision tree is generated first. Decision tree generated first. Decision tree generated first. Decision tree generated first. And then non-significant branches are removed. Where 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 non-significant branches are removed. Past pruning, also known as backward pruning. Past pruning, also known as backward pruning. Past pruning, also known as backward pruning. Past pruning, also known as backward pruning, is the process where recently is generated first and the non-significant branches are removed. First decision tree generation, then remove all those branches which are not that has no significant. That means cross validation set of data is used to check the effect of pruning and test whether expanding a node without make an improvement or not. Second point, tell us cross validation set of data is used to check the effect of pruning and test whether expanding a mod without make an improvement or not. Cross validation set of data is used to check the effect of pruning and test whether a spending in not without make an improvement or not. Cross validation set of data is used to make the effect of pruning and test whether expanding a mode without make an improvement or not. Once read yourself, please, guys. Cross validation, cross validation, cross validation, cross validation set of data is used to check the effect of pruning and test whether expanding a mod will make an improvement or not. If any improvement is there, then we continue by expanding that node. Else, if there is reduction in accuracy, then the mode not be expanded and should be converted into leaf node. If any improvement is there, then we continue by expanding that node. Else, if there is a reduction in the accuracy, then the node not be expanded and should be converted into leaf node. Once ready, you guys, please. If any improvement is there, then we continue by expanding that node. That means if there is any improvement there, then we continue to expanding that node. We have to expand that node only when there is improvement. This is the meaning of this. If there is improvement, then we have to expand that. If any improvement is there, then we have to continue to expand that. And more other else, if there is reduction in accuracy, then node not be expanded. If there is a reduction in accuracy, then the node not be expanded. When reduction in accuracy is there, so we don't continue the expansion and should be converted into deep node. Okay, condition is there when you have to continue to expand or when you have to stop. If accuracy decreases, you have to stop there and make it is a deep node. Thereby, improvement is there to continue to expansion. That is the meaning of this paragraph. Okay. This technique is used when decision tree will have very large depth and will show overfitting of model. When we do use this technique, when decision tree will have very large depth and will show overfitting of model. This technique is used when decision tree will have very large depth and will show overfitting of model. Okay, this technique is used when decision tree will have very large depth and will show overfitting of model. This technique is used when decision tree will have very large depth and will show overfitting of model. This technique is used when decision tree will have very large depth will show overfitting of model and large depth and large depth and overfitting of model. Large depth and overfitting of model. Large depth and overfitting of model is there, then we have to use above given technique. Okay. This is the pre-pruning and rest of the lecture we will continue. Sorry, I am going to start this, completing this, then we conclude. After completing this topic, I would conclude the today lecture. Okay, pre-pruning, also known as forward pruning. 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 Pre-F R Pre-pruning, also known as forward pruning, stops the non-significant branches from generating. Stops the non-significant branches from generating. Stops non-significant branches from generating. Thus, stops non-significant branches from generating. Stops the non-significant branches from generating. Stops the non-significant branches from generating. It uses a condition to decide when should it uses a condition to decide when should it terminate splitting of some of the branches prematurely as the tree is generated. This uses a condition to decide when should it terminate splitting of some of the branches prematurely as the tree is generated. It uses a condition to decide when should it terminate splitting of some of the branches prematurely as the tree is generated. It uses a condition to decide when should it terminate splitting of some of the branches prematurely as the tree is generated. Can be done using hyperparameter tuning. Can be done using the hyperparameter tuning. Overcome the overfitting issue. Thank you guys. I am going to conclude this lecture here, and in the next lecture, I will start from here, and you have to continue your reading so that you get doubt. I am ready to clear your all of your doubt, and if you have any queries regarding this,